You're desperate to discover Google PaLM 2 APIs and interact from Node.js? Relax and keep watching. The genie of the AI lamp will fulfill your wish. Let's go! In this notebook, we will discover and play with Google PaLM 2 APIs. So the structure of the tutorial is quite similar to the one I already made on OpenAI APIs, but I want each video to be standalone. So there will be some repetition, but you know, repetition is good for learning. All right. So please check a previous video to install Jupyter Notebook. Here, we want to declare a function to execute shell command and install the necessary Node.js modules. So I execute the command. The modules are ESM hook, to use ESM modules with Dero setup in our notebook, dotenv to manage environment variables, the Google Cloud AI Platform module, which is the official binding library for VertexAI APIs, and finally the LangChain in the JavaScript version, which is a well-known AI framework. So let's install those modules also. And while it's installing, let's talk a little bit about Google Cloud Access and Authentication, because as a prerequisite, we also need to deal with that. Okay, because we will access the PaLM 2 APIs through VertexAI, and to do so, we need to connect to the Google Cloud console. Here's the link. Then, there you will activate, if necessary, the VertexAI API, create a service account if you don't have one already, and an API key. Also note the location parameter, because we will need it later on. You know, like, is it in the US, is it in Europe, in which country, what is the location where the API is accessed. Save the JSON file associated with the API key and set a Google application credential environment variable pointing to it, like this one. Okay, so save it, like for instance in a .env file. We will also use an access token to call Google APIs in some of the example that I will show you. So to do that, install and launch the gcloud CLI to generate the token. So what you do, so here the installation of the NPM is okay. Everything is up to date, by the way. So now what we do is we also need to install, as I said, the gcloud CLI, and then run the gcloud of login command to authenticate through the browser to the Google Cloud SDK. Okay, that will generate a token that you can display then by typing this command. So gcloud of print access token. So this will generate a token. This token you copy and you store also in the .env file under the Google Access token. Okay, so for security reason, I just export those environment variable outside the notebook. Okay, so now everything is okay. We are all set. Let's go and play with PaLM 2 APIs. So what are those APIs? So PaLM 2 offers several APIs. There are multilinguals, and they give access to LLM and to models. So the first one, the first API is text. It's basically for text task that can be completed in one call. So there's no need for continuous conversation to realize the task, which is different from the second one, the chat text one, which is a fine-tuned model that is providing the answers, and in a multi-turn conversation way. So you have history and you can give more context. Okay. You also have the text embedding API and model that embeds text input and transform them into vectors, as I explained in a former video. And then you have the Codey family of languages, of large language models that are related to code for code generation, code chat, and code completion. So we'll visit also the image and model, multimodal models, but like Imagen or Gemini, but in another video because it's quite different and it's quite new. Okay, and the models were announced to come in 4 different sizes, gecko, otter, bison, and unicorn, with gecko being the smallest. All right. So just here is the repetition I was talking about. We have several abstraction levels when we want to communicate with AI component and large language models, and so with the APIs. The level 0 is through direct API calls. Then you can use also binding libraries, you can use abstracted framework, and you can also use no or low code solutions or even applications. Here in this tutorial, we will visit the 3 first levels. So let's start with level 0, which is simple API calls. And we'll start with APIs that we call from Node.js, but it could be done just like with the curl command here. Okay, so let's try and test the text completion API. So we'll use the text Bison model to do that. Okay, and it's quite similar to the OpenAI completion API that is now deprecated by OpenAI. Okay, so note that in the URL that I call, I pass the name of the model. The name is here at the end. Text Bison. I pass also the project ID. In my example, this is the name of the project ID. And I also pass the location. Remember, I told you to note it. Here, we're in Houston, Europe. Okay, and then I call this URL. And I say I want the predict action. Okay, then in the fetch command, this is a post method that I use. I here load from my .env file the Google Access token and set it in the headers part of the call. And then in the body, I just use a JSON object where in the instance property, I use the prompt and I say, please say hello in Spanish, for instance. And here are the parameters to a little bit change the behavior, the way the LLM will answer. So the temperature, the number of max token for the output, and other several parameters that I won't detail here. But this is where you pass those parameters to the model. Then I wait for the response, and then I'll navigate into the answers and display the content that I want to deal with. Okay, so let's run this command. So here is the promise, and here's the answer, which is hola, so in Spanish. Okay, now let's do chat completion. Basically, it's the same way of doing it, the same kind of URL. This time, I changed the name of the model. I want to use chat Bison to do chat completion, chat text completion. I still give the same kind of parameters for the access token. I use this time in an instance is a message object because it's a multi-turn, but I just have here for simplicity one message, which is the author is a user, and the content, the question, the prompt at the end is why is the sky blue? Okay, and I didn't change the parameters, so I do the same thing. Ask and display the result. Here is the answer. Okay, perfect. So that's it for level 0. Now, if we move up the abstraction level and to level 1, now we'll use the VertexAI's Node.js module. Okay, that allows to call the same API. Okay, so what I do here in the code, I will do the same, just for the sake of comparison, the text completion part. So I declare some variable that I will use. You remember, it's the project ID, it's the location. I require the Node.js module that is called Google Cloud AI Platform. I detail which is the publisher, it's Google, and which is the model, it's Text Bison in the version 001. Okay, and then I create a number of objects, internal objects from the Google Cloud AI Platform library. The first one is to call the prediction service client, so it's AI platform. Then I instantiate a client, and I give the API endpoint as a parameter. Then I declare a helper object that will help to translate the results sent from the LLMs. And then I create my predict asynchronous function that will use a endpoint as a parameter. So remember, we're reconstructing the same URL that we were visiting earlier with the project ID, the location, the publisher, and the model. All right, my prompt will be say hello in Turkish this time. Then for the instances, I just translate all this information with the helper function to have everything properly formatted for the LLM to function. You remember here the same kind of parameters that we used also before. Same thing, we transform them in a proper format. And then finally, we create a request with the endpoint, the prompt, and the parameter passed as parameters. And then here is the predict request. So we wait for the result, the return, when we call on this prediction service client, the predict function with the request passed as a parameter. And then again, I will navigate within the answer to display the result. And then I call the function. Here, we execute the code. So you see it's running here because you have the star. And then here's the result, merhaba. Okay, so hello in Turkish. So you see here, we didn't use the access token that we created earlier with the gcloud function, but we use the JSON file, the API key that we also declare in the .env file. Okay, so different way of authenticating to VertexAI. Okay, so that's interesting. You see there's quite a lot of code if you compare it to the previous codes. So you say, okay, it's a little bit verbose, but you have to remember that the module that we use here, the Google Cloud API platform, is part of a larger project, the Google Cloud client libraries. So it's a very generic one. That's why we have a lot of objects to declare and to create to have everything set properly. Okay, but it's very generic. That's why. Let's play with embedding also and use the embedding API. So it will be the same kind of call. This time the model is different. And the call predict function, I reconstruct the API the same way. That this time in the instance property, I will use the content parameter and say I want to vectorize, to translate the value, the meaning of this sentence in a vector, in a mathematical object. Then I do the same kind of things that I did just before. I instantiate everything, reformat everything, declare the parameters, and then call the same thing, prediction service client predict, waiting for the answers, and for each prediction, log the result. Because you can have, depending on how you parameterize the call, you can have several predictions. Here, I will execute the code now. Here. And what do we have here? We have a vector, which is displayed here. So we have the 101st value. So you see it's floating values. It's a number value. And it's a total of, so 100 plus, yeah, so it's 868 dimension. So this is the dimension, the dimensionality of the vector space on the embedding vector space used by PaLM 2. Okay, so this vector is equivalent to semantically to this sentence. All right. Okay. Now let's move up again and let's use a more abstract solution with the LangChain JS framework. So LangChain is a well-known framework coming from the Python ecosystem, but it was also ported into JavaScript. That's what we'll use. Okay, and the idea is to have more concise code, as you can see. If I do the same kind of stuff that before, here for the text completion, what I do is I just require the part relative to Google VertexAI from the LangChain module. Okay. Then I parameterize, I instantiate and parameterize the Google VertexAI, and I just give here, for instance, temperature, but I could give the other parameters. Okay, and then I create an asynchronous function just to call given a prompt, the LLM, and display the result. So let's run, and this time let's learn how to say hello in Mandarin. Okay. Okay, so it's written with ideograms, but I also know that it's pronounced like ni hao. All right, so everything's working fine. You see the code is more concise. That's one of the advantage of using abstracted framework like LangChain. It also have some choices that were made by the creators of the LangChain framework, yes, but it's easier to use and to implement. Okay, now let's do the code completion, because we didn't test that. I skipped the chat completion part. It's basically the same kind of stuff that we did before already. Now let's play with code. So first with code completion. So the idea is to start some code like here, and then ask the model to finish. All right. So this time I use the code gecko model, and then basically I do the same kind of call here, and the prompt that I will give in entry is the start of a for loop, and we'll see how it goes. All right. Okay, and now you see that Codey or code gecko just finished this line of code. All right, that's nice. What about generating some code? So from text to code, which is the code generation model, the code Bison one. All right, so we just changed the name of the model here. And what I want the LLM to tell me is to write me a function in JavaScript that checks if a years is a lib one. All right, so let's execute this one. And here we are. So you see the code here. You see that actually that the format is kind of markdown. This is the markdown instruction to highlight the code. I didn't work on the notebook to display it with syntax highlighting, but basically you see that the code here is written here. All right. Okay, so that's cool. Right, now let's move up and try to implement the Retrieval Augmented Generation architecture pattern, the RAG. So you remember, or maybe if you didn't check it in a former video, I explained a little bit. The idea is when we call the LLM is to inject into the prompt some contextual information coming from document and data source that we have locally, to give more information and ask the LLM to use this information to make the answer. All right, so we'll do that by using one single PDF document coming from slides that I did convert in this format. And I'll use also an in-memory database called vectorstore to store the vector associated to the content of the PDF. All right, that's why we do some embeddings. That's one use of the embedding, for instance, API, is you call the embedding API, giving some part of the PDF file and store the vectors that are returned. Then, when you make a call to the LLM with a prompt coming from the user, you first do a call to this vector store to get the most relevant part, the most relevant vector that you will inject into the call, and then you will ask the LLM with all of that to make a proper answer. Okay, so let's see how it is done here. And that will be the last part of our tutorial. So we require, again, the Google VertexAI embeddings this time, because we will use it. We will retrieve also the retrieval QA chain, which is a predefined template to realize all the action, all the steps that I described just before, like chunk the PDF files in several parts, ask the embeddings, get the vectors back, store them in memory, use them to inject in a prompt sent by the user, for instance. So for that, I will need the memory vector store, and I will need also a PDF loader to be able to open, access the PDF content, and convert it. All right. So I create my Google VertexAI object. I create my embedding. and I get the PDF completion by loading my document, so techsquad.pdf, that is stored on my local hard drive. Then I load the document. I create a vector store in memory with the content of the document and the associate vectors returned by the embedding model that is called automatically by LangChain, because we're using this one, the retrieval query chain. Then I create the chain, that's why it's done. So with this model, with this vector store, okay, and then I just have to call the chain, and with my query, what is the text squad? So basically, I want the answer to take into account the content of this document to answer and to make the result. Okay, so let's try. So things are being executed, and then here is the result. The tech squad is a group of 50 elected tech experts in Worldline, whatever. So you know that it's contextual information, because basically PaLM 2 was not trained with information, that kind of information. The information is really coming from my injected context. And Google is not storing the content of the document. So it's a way of customizing things and have a more precise and contextual answers. Okay, so that's good. That's all for this short tutorial. We'll visit abstraction level 3 and 4. You remember no-code, low-code solutions, and also application using PaLM 2 model in another short video. And that's it for now. Keep making wishes, and maybe the GenAI's lamp will fulfill them. Stay tuned. Bye-bye.